Hello everyone, my name is Feng Zhifan. I come from the Knowledge Graph department of Baidu company in China. My main research directions are knowledge graph, semantic understanding, and video understanding. Today, I will give a report on our work. The outline of my report is as follows. Firstly, I will introduce the relevant background. Secondly, I will introduce the overall structure of my work. Thirdly, I will introduce the technical solution of knowledge-enhanced named entity disambiguation model in detail. And finally, the explanatory analysis and summary. Named entity disambiguation aims to associate each entity mentioned in the text with its corresponding entity in the knowledge graph. It plays a very important role in many text-related artificial intelligence tasks, such as search engine, recommendation, Q&A, as shown in figure for a sentence. What famous ports written by NED by named entity disambiguation system, NED will be associated with entity NED, which is a famous port in ancient China. Though disambiguation, we can understand the knowledge in the text and assist in the intelligent application. It's very difficult for existing method to make decision on the low understanding utterance without the required context. Named entity disambiguation for the short text is still a challenge. First, noisy and scarce in the short text. Secondly, the multi-ambiguity of entity is more serious for the short text because of missing context information. Human beings can still perform recognition by association with related external information such as common sense or domain-specific knowledge. It is inspired us that learned on short text can be improved if appropriate external knowledge can be retrieved and considered. We propose a lower knowledge-enhanced knowledge model, where the procedure of learned is enhanced by two kinds of knowledge formalized as two kinds of cases. The one kind is conceptual knowledge, and the other kind is factual knowledge. As shown in the figure is the architecture of our proposed entity disambiguation model knowledge-enhanced named entity disambiguation. We adopt the deep structured semantic model as the baseline model for alert. Based on self-attention machine learning network, DSSM mappings the candidate entities and the context to the same semantic space and finds the candidate entity that best semantically merges the context. For short text used in information acquisition scenarios such as information retrieval and question answering, the lack of both lexical and technical information obstacle the process disambiguation of entity mentions. For human beings, however, the problem of information scarcity does not hinder the disambiguation procedure. This is because there are many implicit assumptions and a priori knowledge in these information accuracy scenarios, which can be effectively considered by association and imagination during disambiguation procedure. Inspired by this, we propose a knowledge-enhanced natural model for short text, where two kinds of knowledge are introduced to provide additional information for bad disambiguation performance. The overall procedure of the NED model is a pipeline including feature extraction and semantic matching. The feature extraction sub-procedure for mentioned text is enhanced by conceptual knowledge, and the sub-procedure for candidate entity is enhanced by factual knowledge. A concept is a name or label representing a material existence such as a person, a place, or thing. For example, the entity apple may be corresponds to the concept of root, a person, movie, song, and so on. For a mention with a concept and use the concept representation as an additional feature representation of the mention. Different from traditional methods, where mentions are classified into categorized entity types. The concept labeling procedure in our work classifies the mention into fine-grained concepts, which can better utilize the concept of the mentions and provide more information for disambiguation. The concept of the fine-grained is more detailed representation of the concept of coarse-grained, or can be considered as a deep level of disambiguation. We adopt a graph-based labeling of algorithm for concepting labeling. As shown in figure, give a short sentence. It first builds a large feature network graph based on the short sentence and reference conceptual factual keyes, which is called subgraph construction. And then we search for the property concept for the mention by performing a random walking method on the graph. The KFN is built according to the correspond between the symbols in the short sentence and the reference keyes. The symbols include word, entity, mentions, and the candidated concepts. As shown in the figure, the word is song, entity mention is nearby. Candidate concept includes single, poet, song, person, and so on, while the word and mentions are obtained by lexical analysis and entity recognition, and the concepts are obtained by matching on the reference keyes. The KFN describes three kinds of the relationship, that is the relationship between entity and concept, the relationship between concept and other concept, and the relationship between word and concept. The overall method is as follows. Firstly, initial the weight of the nodes and the edges of KFN. The concept and the entity relationship is represented by the generation probability from concept C to concept E. The concept and concept relationship is represented by the transition probability between two concepts. The word and the concept relationship is represented by the labeling probability between the word W and the related concept C. The probability is calculated based on the word frequency and the word concept co-occurrence frequency. Secondly, we performed a random walk algorithm on the knowledge graph, network graph, to get the concept of the entity mentioned. According to the formula, we can get the final concept result. It varies by the wide use of the distributed representation of KG entities in many NLP. We think that such knowledge representation is worth to have for in NED. In this work, we use both textual and knowledge representation to better represent the semantics of candidate entities. We get textual knowledge of entity from its description. First, a predictive sample is generated by entity description from KB, such as Wikipedia, and then word segmentation is applied into the entity description text. We have called it the word frequency in predictive samples and the negative sample are generated by band frequencies random sampling. In order to get the relationship between the entity and the enhanced entity representation, we use also entity co-occurrence data and knowledge-based SPO data and structural entity knowledge. Entity co-occurrence sequence is extracted from KB hyperlink, SPO triple from KB, which are extracted from the key value block of the Wikipedia. Based on the related textual context and other information of the entity, it used the symbol model with a sigmoid layer to generate the distributed representation of the entities. Then we update the entity embedding representation with skip-ground model to enhance the inter-entity relationship. Finally, we obtain at the final entity embedding, which as a feature representation of entities into a KG-enhanced entity disambiguation network. We have experimented on both Chinese and English dataset. For the Chinese experiment, due to the lack of the large-scale short-text entity disambiguation dataset, we constructed a dataset called DoEL to use it as the Chinese experiment dataset alongside the full-time dataset. Our dataset provides a high precision annotated entity disambiguation dataset consists of 100,000 short text, 3,560,000 entities. The text covers many from the webpage title and the search engine query in actual application, and we allocated the entire short text in the dataset by crowdsourcing. Compare the proposed method with several state-of-art approaches both for Chinese and English dataset. We choose standard micro F1 score as our performance metric. The experimental result indicate that our approach cannot outperform existing SOTA methods. Data analysis demonstrated that each short text contains 3 mentioned entities on average, each of which includes 20 ambiguous entities to be linked, and the connect is both. Experiments demonstrated that knowledge enhancement is very helpful for Chinese short text entity disambiguation. As listed in table, DSSM represents the fine-grained dynamic conceptualization components, and ECE represents entity context embedding components. For the disambiguation problem entity nearby, we can see that correct fine-grained conceptualization is helpful to corrected disambiguation. In addition, for syntax, wedding photos of nearby and Sabinin, although nearby can correctly label as concept pattern, it may lead to disambiguation errors. Then, though use of structural knowledge, it can be correctly disambiguated. Therefore, in the disambiguation problem, the two kinds of knowledge can play a complementary role. And the following is a summary of the work. We propose a knowledge-enhanced approach to short text entity disambiguation, and we construct a very large-scale and loaded Chinese dataset for short text entity disambiguation and released it. In the future, we will use more modern embeddings such as BERT or encoding such as transformer to obtain better embedding, and we also plan to do more conductive experiments to verify the effectiveness of our method in other tasks such as QA, dialogue, and so on. Thank you very much.